Securing the design. During the design stage, you start taking the requirements and putting them to paper, coming up with what is the final product going to look like. What is it going to look like? What does it need to do? Security should be a consideration there too. Your design must incorporate security concerns, otherwise, again, you're going to be scrambling at the end to try to backfill it. In your design, you may not be able to account for all potential risks. You may have external dependencies. Some of those external dependencies may be single points of failure. It's one of the requirements of having a secure design to be able to get around that and to deal with that in a secure fashion. One of the things that you need to get into the developers' minds as you start doing your design is that the only consideration is not scalability versus performance. Security is something that needs to be considered in there as well. Threat modeling and architecture review. Threat modeling can begin in earnest, the actual process of it, once your product is feature complete. Once you know what it is that the product is going to do, you can begin driving out how the security is put into that. It becomes much more physical and much less theoretical at this stage. One of the critical components of doing the threat modeling at this stage is knowing what your inputs and outputs are. What are the ways, what are the entry points to the application? What are the exit points? And also the transfer points within the application as well. If you have a distributed architecture of, let's say you've got a 3-tier system, you don't just need to be concerned about what's going on tier 1. You need to be concerned about the entries to tiers 1, 2, and 3. Code review. Code review is most effective if it's initiated as sections of the code go code complete. Reviewing code that's still subject to change or is not feature complete yet is a recipe for disaster. What's going to happen is you will review code and the code will change after it's already been signed off on as being secure code, and it won't be once in the final product. One of the advantages of using threat modeling in the process is that it allows you to analyze the overall architecture of an application and come up with what are the critical pieces that need to have the low-level analysis done with them. Where are the efforts as far as doing a code review best spent? Things like your session engine, your state engine, your authentication mechanism. Those are going to be the critical points that people are going to attack first. They're the soft, vulnerable part of the application. It's your job to make sure that they're protected as best as possible. Using threat modeling allows you to drive out what are those parts. Penetration testing. In addition to the standard, hire somebody to come in for a few days and poke around and see, jiggle the door handle, see if they can open anything up. Other things to consider as far as this stage of the life cycle go are, what are some products that are similar to the one that we're creating? Have those products had vulnerabilities found within them? If so, are we at risk for those same vulnerabilities as well? Another thing to think about is third-party libraries that your application may use. If those third-party libraries are vulnerable, then your application is vulnerable too. Securing deployment. One of the trade-offs that developers need to, and project teams in general, need to face within the dev cycle is what's the most appropriate way of securing an application. One of the problems with that is that the most appropriate way of securing an application may not necessarily be the best way of securing it. A classic example of this is the radical change in how Microsoft products are installed by default. You look back at SQL 6.5, the SA password was blank by default. Nowadays, if you want to have a blank SA password, you have to go through a couple of prompts that say, this really is not a very good idea. That's an example of an implementation or a deployment consideration. There are some instances where the most secure deployment may not work for a large portion of your customers. In order to deal with that, it's crucial that any security features of a product be well documented. Integrating feedback into the lifecycle. Once a product has been released, obviously you're going to be receiving feedback, both from customers saying, I wish it would, to customers saying it really shouldn't, to anyone and everyone saying, this is actually a pretty big risk here. One of the things as a dev team you need to do is have a process in place following release of your product to integrate the feedback either into the next version or into any patches that you need to issue. You have four primary roles that are involved in application security. The first role that I'm going to discuss here is the architects. They are the ones that design the foundation of the system. Obviously, given that they're the ones that are creating the blueprints for an application, having their involvement with security practices is very important. By having them involved, you can head off a lot of risks and a lot of headaches that you may run into later on. Developers, obviously, they're the doers. They're the ones that do the code, that make the magic happen. They're also the ones that have the most intimate knowledge of the technical aspects of an application. As a result of that, they're also one of the primary sources of information as far as the threat modeling process goes. Not only are they one of the primary sources of information, they're also one of the primary consumers, because they're the ones that are going to implement the changes that come out of the threat modeling process. Testers. Most organizations that I've had experience in, testers have been fairly isolated from the development process. If involved at all, they've been involved very far on the backside after everything is code complete. That's not the best way of driving out security. Having testers involved throughout the process allows the testers to become a questioner as far as the application and the infrastructure of that application goes. They can be a counterbalance. They're an outside party from the dev team. They're not involved with the development of it. By taking that role and not just making sure that the functional requirements of an application are met, they can help drive out security. Management's critical in application security. They're the ones who have to answer the question of how much money can we spend and how much time can we take in making our application or product secure. One of their responsibilities is demonstrating the return on investment for any of the security work. They're the ones that are ultimately accountable for the security of the application. So now that we've covered a background, we're ready to get into what is threat modeling. There are three main parts to it: understanding the adversary's view, characterizing the security of the system, and determining the threats to that system. As far as understanding the adversary's view goes, you have entry points, assets, and trust levels. Entry points, fairly obvious. Any location where data or control transfers between the system being modeled and another system. Another way of looking at that is, how can an adversary interface with my system? An application can't be attacked unless an adversary has a way of interacting with it. An example of that is, I don't know how many of you remember Microsoft proudly proclaiming that NT4 is C2 compliant. Well, yes, it is. It could be made C2 compliant. It certainly was not out of the box by installation defaults. Some of the things you had to do as far as making it C2 compliant were to remove the network adapter and either remove or epoxy any sort of removable storage. So, sure, it's C2 compliant, but that's because there's no entry points at all to the system. Assets. What are the resources or components of a system that an attacker is going to go after? It's impossible to have a threat without a corresponding asset, because the asset is the threat target. Assets are both tangible and intangible. You can have tangible assets like a process token or a database table, but you can also have intangible assets, things like data consistency and relational integrity. If you can affect an application at that level, then you definitely have the ability to wreak havoc within the application. Defining use scenarios. I don't know how many of you guys are familiar with UML and use cases and all of that good stuff. Threat modeling takes use cases into account and uses them as an input to the process.